practice drawing different types of structural formulas with different given information as well. So, if you haven't watched this or are not familiar how to draw expanded, condensed, and skeletal formulas, I have a separate introductory discussion for that. But here, we go straight to the point and answer the following. So, we start with this one. And here we are given an expanded formula, and we want to convert it into condensed and skeletal. So for the condensed, this one is rather easy. This is going to be CH3, and then this one into this one is just CH, right? However, we know that this is a branch, and so we're gonna have to put that in parentheses. Okay, and then this one is going to be CH2, and then this one is CH3, and we are done. This is basically a reminder to use your parentheses when you branch out. Okay, let's put this a little bit here. Right. How about skeletal? This is going to be even easier because I have here 1, 2, 3, 4 carbons. So that would mean 1, 2, 3, 4. And then the branch is on the second carbon. So this is the second carbon. I put it there. And again, all hydrogens are invisible if skeletal, and this is basically done. How about the second example where we have a condensed formula? Here, it's up to you if you want to start here or here. But I think skeletal is easier, so I'll just do that first. I see here that I have a carbon at the end, and then I have another carbon at the end, so that's 2. But I have 6 in the middle, and the fact that it's in parentheses means that you just draw it straight. So if I add that, 1 plus 6 plus 1, and just draw 8 carbons in a straight fashion. 1, 2, 3, 4, 5, 6, 7, 8. Okay? But of course, if I'm going to expand that, it's gonna be a bit of a hassle. But we're gonna have to do that 1, 2, 3, 4, 5, 6, 7, 8, and then just make sure you complete the hydrogens. This should be CH3 because I need 4 bonds for this carbon as well as this one. And then every carbon in the middle has 2 bonds already, so I just need to supply 2 more to become 4, right? So like this. And really, this is one of those situations where it's already easy and you're gonna just have to be careful about making sure you don't miss a hydrogen, right? So this carbon has 1, 2, 3, 4. This carbon has 1, 2, 3, 4. This carbon has 1, 2, 3, 4. And you can continue that until the end. Now let's go to the third one here. So I have here a different atom this time, which is OH. And we're gonna have to probably start at the expanded since it's easier to visualize. I have 1, 2, 3, 4, 5, 6 in a straight fashion. So 1, 2, 3, 4, 5, 6. Right? And then the fifth carbon has this OH. So this fifth carbon will have the O, which has an H. And if we want to expand it, even the single bond of the O and H should be expanded or written. And then just make sure you complete the hydrogens. 1, 2, 3. And then for this one, and then for this one, and then for this one, and then for this one. And then take note that for this carbon with the OH, it has 3 bonds already. So you just need 1 more bond to become 4. Now, if we're going to condense that, then of course, this is CH3. Then for this one, it's really up to you if you want to write it separately as 3 CH2s. But if you want to make it the shortest possible way of drawing, it's going to be CH2, 3. And then this will be written as CH. And then since the OH does branch out, you need to put that in parentheses. And then the last one will be written as CH3. So again, if you, just to show you how it would look like if ever, but if you want to write that as CH2, 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 that is still correct. This is 2. But again, the shortest possible way of writing its condensed version is like this. Okay? How about this? This time, you can see that we have this straight chain, but the second carbon has not just 1, but 2 branches. So if we're going to do that in the condensed form, this one will be CH3. And then this carbon will have these two. And if you notice, this carbon doesn't have any hydrogen anymore, right? So we will be writing that as C, then open CH3, 2, because this refers to these two. And then go back to the linear part. We just have one more CH3 left. And this is done. Okay. And when I go skeletal, I mean 1, 2, 3. So that's 3 carbons. And then it's up to you how you want to write these two branches. You can go ahead and write it like one on top and one at the bottom. Or I think sometimes it's gonna be written like so. Either way, it should mean the same thing. In my experience, I think writing it like this, as if it's an X, is the more common way to go. Because since it's spaced more evenly. And in the future, when we discuss other properties of organic compounds, we want our bonds to be distanced as equally as possible. How about this one? So, um, I think we're gonna go expanded again. Okay. I just feel like it. So this one is gonna be CH3. So CH3. And then this carbon has two branches, right? So again, it's up to you if you want to write those both on top, both on bottom, or one on top and one on the bottom. But this carbon is gonna be this. This chlorine, I'll just put it up, and this methyl is at the bottom, or CH3. Okay. And then this one is just CH2. And then this one is CH3. So if I'm gonna go skeletal, it's gonna be 1, 2, 3, 4 in a straight line. And then again, it's up to you if you want to put the chlorine on top and the extra carbon on the bottom. You can also opt to do it like this. It doesn't really matter. Like for example, you put the methyl on top and chlorine at the bottom. Anything would do as long as we understand that both of these substituents are branches of this carbon, like here, and as you can see, like here. Now, what if we have a compound that is this, which we call a cyclic compound? It closes in to form a shape like in this case, a hexagon. I think it's easier to write the expanded formula. So I have carbon and I make the same shape. And then I have this nitrogen, N, and then its two H's also have to be expanded. You can write the lone pair if you want. Depends if your teacher requires it. Now, for this carbon that contains the nitrogen, it has 3 bonds already. So how many more do we need to become 4? Just 1. So I'll put 1H. But for all other carbons that do not have the nitrogen, what do you see? This carbon has only 2 bonds. This carbon only has 2 bonds. This carbon only has 2 bonds. So across the board, all of them have 2 and they are just missing how many more to become 4? They are missing 2 more. So consistently across the board, all the other carbons are just gonna be CH2s, right? CH2s. That's it. Now it's a little tricky if we condense it, and personally, the way I see compounds in the many years I've seen compounds, we don't normally see condensed versions of cyclic ones. But if we can force the issue, we can definitely write that as CH2. And then you can just go ahead and do the same for all of them. And then this carbon only has one H, so I just write CH. And then you may probably write NH2 here, or some would most likely expand it or add a line to separate the NH2. Okay? Just one thing that you need to consider when writing CH2s or CH3s is that try as much as possible to make sure that the line goes to the carbon and not the hydrogen. Because though it may not be the most important thing in the world, if for example you have a bond going to the hydrogen, that's wrong because you know that hydrogen can only have one bond, so you cannot put it in the middle. So make sure you reflect that if your expanded connects the carbons, then they should be the two letters being connected also. in the in the condensed version. And then for the last one, we have here a triple bond for the first time. And if we're going to expand it, you need to be a little careful. There's a reason really for this, but if you find this weird, what is going on with this counts as a separate, or these two count as separate carbon atoms. We will learn that there's something about the geometry of triple bonds that we cannot bend it already here and we need to make it straight. But if we count the carbons, that would be 1, 2, 3, 4, 5, 6. So if I expand that, that's 6 carbons in a row. 1, 2, 3, 4, 5, 6. And then, just to reflect this and this, I need to note that my triple bond is at the middle of the third and fourth carbon. So it would be this one, right? Third and fourth. And then the bromine is at the fifth. 3, 4, 5. So that would be here at the fifth, right? You can put it up or down, it doesn't matter. And now, time to complete the hydrogens. So carbon only has one, so I need 3 more. This carbon has 2 bonds, so it just needs 2 more. But notice this triple bonded carbon. You notice that it has 4 bonds already, so we're not going to add any H anymore. And that is also mirrored in this carbon. It's already complete. So you leave that behind. But for the carbon with the bromine, it has 3 bonds, so you still need to add one to make it tetravalent. And then the last carbon just has 1 bond, so you need 3 more. And then finally, just to condense it, it would be something like this one is CH3, this one is CH2, then C triple bond C. Again, I stated previously in the other recording that you may choose to just write it without the triple or double bond, but for introductory purposes, it's really standard to just write it as well. And then this one is CH, and then that's when we branch out the bromine, so parenthesis. And then finally, CH3. So again, I hope that we were able to recall how to use parentheses, what we can condense, how to expand, and make sure that the number of bonds are correct, right? Like for example, this nitrogen has 3 bonds, okay, or the chlorine only has one, so it doesn't have an H. And we will need to know how to consistently draw correct structures throughout all of the other fundamentals that we will learn in organic chemistry.